So let us take some very simple examples based on the model e power x times fx plus f dash of x. So the questions might look like this: integration of e power x times x plus 1 dx. So what is the answer to this question? E power x times x plus 1. So you have an e power x here, you have some function of x here, and what is the differentiation of x? 1. Some f of x plus the differentiation of this f of x. So the answer is e power x times f of x, that is x times e power x plus c. So that will be the direct answer to this question. So next, if you have integration of e power x times tan inverse x plus 1 by 1 plus x square dx. So here also you can clearly see that you have an e power x outside. Within the bracket you have tan inverse x plus its differentiation. So if you have function plus its differentiation, the answer is e power x times the function f of x. That is e power x tan inverse x plus c. Next, if you have integration of e power x times log x plus 1 by x dx. Log x plus 1 by x dx. Now the question looks like e power x times some function of x. Here it is log x plus its differentiation. The answer is e power x times log x plus c. So e power x times log x plus c. So if you have integration of e power x times sin x plus cos x dx. E power x times sin x plus cos x dx. So what is the answer here? So if you take sin x as your function, the differentiation of sin x is cos x. So f of x plus f dash of x. So e power x times sin x plus c. So if you have integration of e power x times sin x minus cos x dx. So this time if you take the function sin x as f of x, the differentiation is plus cos x, not minus cos x. So here you don't have the expression in the form e power x times fx plus f dash of x. But this time what we do is, I'll take a minus common outside. So e power x times cos x minus sin x dx. Now if you take cos x as your function f of x, minus sin x is its differentiation. So the answer is minus e power x times cos x plus c. So this is how we apply this formula e power x times fx plus f dash of x dx.